This video is going to have a quick explanation of how to do a linear regression or a line of best fit using Desmos. So I have a data set over here. I have my X and my Y. I have Desmos up, the North Carolina testing version. I'm going to go onto Desmos. I'm going to create the plus sign because I want to add a table because I need to put in my X and Y values. So my X's are 1, 3, 5, 7, 10, 10, 13. Then I'll go up to my Y's. It'll be 24, 29, 30, 32, 42, and 48. Now, since I have it right here, it's blue with the dots on here, I can hold down on that and I can see that I want my points. I could also have them as circles or I can have them as X's. But I'm just going to keep them as points and they are blue. Now notice I don't see anything on my graph right now because I have my values at 0 to 8 on the positive X, and then on the negative X it's 0 to negative 10. My X's are from 1 to 13, but my Y's, notice that I only go up to 8, but my first Y value is at 24. So I actually can change my, my scale for my window, or I can just zoom out of Desmos and I can make it come smaller, and I can then see my points here. Now, if I go to my little wrench here, I can say that I want my X's to start at 0, and I can say since my largest X value is 13, I can say I want to go to 15. Then my Y values, I can just have a step by 1, so I only want to count by ones. And then for my Y's, I have no negative Y value, so I can say my Y value would be as small as 0. And it looks to be the highest Y value is 48, so I can say I'll go to 50 on that. But I might want to count by 5s on that. So now I can see all of my points. They are solid. If I had click that and hold down, I can change that to be circles. I can have them as X's as well. But again, I just want them as little points. I can also change the color if I want to. Now, the reason why I put this on here is so that I can do a line of regression so I can find the line of best fit. What you really need to know for any type of best fit or regression equation is the parent graph, the parent function. For a line, because this looks to be linear, it's not a complete linear because it does not go on a line. One line cannot go through all the points, but it looks to be pretty linear. So we can get that line of best fit. So for any regression, if you know the standard form or the parent function, then you can write the regression for any type of function. Y equals mx plus b, I'm just going to type that in, mx plus b does not help us. But what we can do is we can change this to be the regression equation by changing it from y equals mx plus b to y sub 1. So I just put a 1 beside it because I'm using y1 and x1. I can also have mx1 plus b. But it's not an equals to because we know that it's not the actual line. So instead of an equal to symbol, we use the tilde, which is the shift and then the button beside the 1. Now, this is our equation of the line. We have our m of 1.97 and our b of 21.33. We also have the r value of 0.979, which means it's very close to 1, means that this is a very strong correlation. So this is a line of best fit. Again, if I wanted to use any type of regression, as long as I know the original parent function, I can use that to find any regression. So if I wanted to do a quadratic, the quadratic parent function would be y equals ax squared plus bx plus c. And the way to change this is the y's would need to be y1, the x's need to be x1s, so I would need to make sure I have that as a subscript on both of them. And then I need to change from the equal sign to the tilde, which is that shift and the shift right beside the 1 button. And then I have my A, B, and C, and this is not a regression of best fit because this is not quadratic, but this is just to show you how you can do regression on Desmos. So again, our regression on Desmos, this line goes through many of these points, and it has an R value of 0.979, which means that it is a strong positive correlation.